Express 3 over 2x minus 1 times x plus 1 in partial fractions. So that means we're going to write it, we're going to rewrite in the form a over 2x minus 1 plus b over x plus 1. So we are going to say that 3 over 2x minus 1 times x plus 1 is equal to a over 2x minus 1 plus b times x plus 1. Then we're going to multiply through by the denominator. So that will give us 3 equals a times x plus 1 plus b times 2x minus 1. We can find out what a and b are by substituting values in for x. So if we let x equal -1, -1 plus 1 will be 0, so a will disappear. It will get rid of a, so we'll only have b left, and we'll be able to find out what it is. So when x is -1, we have 3 equals 0 a's, that's disappeared, plus b times 2 negative ones, -2, take away another one, -3. So 3 equals -3b, b must be -1. B must be -1. How about a? So we could let x equal 1/2, and that will get rid of b. So let x equal 1/2. That will leave us with 3 equals a times 1/2 plus 1, 1.5 a's. A must be 2. So a is 2, b is -1. So we have 2 over 2x minus 1 minus 1 over x plus 1. That's part A done. Part B, when chemical A and chemical B are mixed, oxygen is produced. Scientists mix these chemicals and measure the total volume of oxygen produced over a period of time. The total volume, V meters cubed, T hours after the chemicals were mixed, is modeled by the differential equation dV dt equals 3V over 2t minus 1 times t plus 1. See a similarity between part A and part B. V is bigger than 0 and t is greater or equal to k, where k is a constant. Okay, so given that 2 hours after the chemicals were mixed, a total volume of 3 meters cubed of oxygen had been produced. Solve the differential equation. So this information here, that's going to be used to find C after we integrate. So solve the differential equation to show that this is what we should end up with. V equals 3 times 2t minus 1 over t plus 1. So our differential equation, dv dt, is equal to 3v over 2t minus 1 times t plus 1. Now, part A and part B look very similar. So we want to get 3 over 2t minus 1 times t plus 1 on one side, and the v on the other side. We want all the t's on one side, all the v's on the other side. So divide both sides by the v. So that'll be 1 over v, and that stays with the dv. The dt times is up to this side, so that'll be 3 over 2t minus 1 times t plus 1 dt. We're going to integrate both of these sides, integrate both sides. And the 3 over 2t minus 1 times t plus 1 we can change using our answer to part A. So we've got 1 over v dv, and we've got the integral of 2 over 2t minus 1 minus 1 over t plus 1 with respect to t. So now we can integrate all of these. They are all going to be natural logs, ln's. So we've got integral of 1 over v dv, that's ln v, 2 over 2t minus 1, so it's 2 ln 2t minus 1, and we're going to divide by the bracket differentiated, which is 2, so that's actually going to cancel out. And we've got minus ln t plus 1, then a plus c on the end. A plus c on the end. So that gives us ln v equals ln 2t minus 1 minus ln t plus 1 plus c. I haven't done any work there, I've just rewritten it. So we've been given the information 2 hours. So when t is 2, v is 3. When t is 2, v is 3. So let's substitute that information in. When t is 2, v is 3. ln 3 equals ln 2 times 2 minus 1, 3, minus ln, what was it? T was 2. That's going to be 3 again, plus c. So ln 3 minus ln 3 is nothing. So c is ln 3. So what do we have now? We have ln v equals ln 2t minus 1 minus ln t plus 1 plus ln 3. And now it's just a case of getting it into the right form. So when we have 2 logs added, we can times them. And we have a takeaway, we can make that into a divide. So I'm going to need to go onto the new page. So we have ln v is 3 times 2t minus 1. And then divided by the one that had a minus, which was t plus 1. And then we've got a log on both sides. So natural log v equals natural log of this. That means those two parts must be equal. So v must be equal to 3 times 2t minus 1 over t plus 1. That's what we wanted. And the scientists noted that there was a time delay between the chemicals being mixed and the oxygen being produced. And there was a limit to the total volume of oxygen deduced from the model. So we should be able to tell from this what the time delay is and what the limit is. So the time delay, that's why t is greater or equal to this k we had here, where k is a constant. Because if you put in when t is 0, you're actually going to get when t is 0, you're actually going to get a negative answer out. Because 3 times negative 1 is negative 3, divided by 1, negative 3. So we want to know when it becomes equal to 0. So when does it become equal to 0? So times both sides by t plus 1, that disappears. Divide both sides by 3, that disappears. So it's where 2t minus 1 equals 0. That's when t is equal to a half. So it only becomes positive if at 0 when t is a half. The amount of oxygen produced is 0 when t is a half, and then it starts getting produced after that. So the delay is a half, and it's measured in hours, so it's half of an hour. So CI, half an hour, or 30 minutes. The limit, what's the greatest answer this to have? It's going to have a maximum answer that it's going to reach. So if we kept putting in bigger and bigger numbers for t, it's going to reach a limit. So what is that limit? If you're not sure, you can just substitute in a really big number. We have 3 times 2t minus 1 over t plus 1. So if I put in 100, what do I get out? I get 5.91. If I put in 1,000, 5.99, and it's going to keep getting closer to 6. So 6 is the limit. 6, and the units, meters cubed. If you didn't take that approach, if you actually wanted to work it out, so you've got 3 on the top. Now this 2t minus 1 over t plus 1, 2t is always going to be double the t. So when t is 100, it's going to be 199 over 101. When t is 1,000, it's going to be 1,999 over 1,001. So it's going to get closer and closer to 2. So it's going to get closer and closer to 3 times 2, which is 6.